Hey everyone, welcome to 5th grade adding and subtracting with decimals. I am Joe Rataski, the DRT, and I'm here with special guest Jack Faley.
Hi everybody, I'm Jack Faley, your kindergarten through 5th grade math supervisor. Excited about this math dive in 5.
All right, Jack, so the first thing we're going to want our teachers to do here, if they're watching this, is to, after these thought bubbles pop up in just a second, I want you to pause the video. So looking at these pictures, what do you notice? What do you wonder? How do these methods connect to whole number addition and subtraction? And which of these is a standard algorithm? So go ahead and pause and think about these questions, and then you can return to the video. Okay, here's our progression getting to this point in 5th grade with adding, subtracting decimals with the best standards. We see in 3rd, they were working with whole numbers. In 4th grade, they started to explore what it would be like to add and subtract with decimals into the hundredths. And right now we're going to be adding and subtracting multi-digit numbers, including decimals, to the thousandths using a standard algorithm with procedural fluency.
Okay, so that's why you asked that question on the previous slide. We're going to dig into that standard algorithm thing, I bet.
You got me. And you may be wondering, what is this procedural fluency? Well, that's stage 3 of fluency, and that is where basically kids have an idea of what it means to add, to subtract, to work with decimals, but they're now becoming fluent, they're becoming efficient and accurate with some sort of procedure.
All right, I see we got some base 10 blocks here, Joe. Now I know that students have used those quite a bit at primary, and this is 5th grade, so why are we still using those?
Well, in the first couple of units about place value and decimals, did you utilize these base 10 blocks at all?
Yes, we did.
You probably did some things like this, where if the rod represents one whole, how do we figure out what the other pieces are worth? Same thing, we can switch the flat to be one whole. And students did that a lot in 4th grade, but we saw in 5th grade, in order to be able to use these with the thousandths place, we needed to make the cube one whole. So now we can represent 3 of our place values. So it really is important that we're still using these, though the goal is to get to standard algorithm or some kind of procedure. We still want kids to be able to see that base 10 relationship and going both directions. So we're connecting back to those place value units. And you probably used the place value mat to place these, right?
Absolutely, we did, yep.
So we can still carry that over and maybe act these out on the place value mat, because eventually we don't want them relying on those place value blocks, but they could draw some pictures. And we really want them connecting with that whole idea of regrouping, how 10 is such a powerful thing. So even when we're adding here, a lot of kids might make mistakes where they're writing 2 digits, say in the thousandths place. They're writing 11, but we want them to see that, nope, I'm still making that regrouping.
Okay, and going back to the base 10 blocks, that'll help with that.
And this really connects to what they did with whole numbers.
Absolutely.
Same thing with subtracting. That whole idea of regrouping isn't just making a group of 10, but also that idea that I can take 100 and trade it for 10 thousandths. And then that makes it a lot easier to maybe cross off, see what's left, and they can act this all out with pictures. So in 4th grade, our 4th graders started working with the 100 grid and the 10 grid. But what do you think that grid with the little teeny tiny squares is representing?
That's got to be like the millionth grid, right?
Close. So these lines, since we can connect to fractions, 1/10, it's our 10th. One of these would be 100th, and now you would say this is the...
So this is the thousandth grid.
Yes. So really, these tenths and hundredths are good for working with tenths and hundredths. The thousandths one they really could use, but we probably shy away from that model once we get into the thousandths place. But a couple of our explorers initially are going to work with just working with the hundredths and tenths, and this is still a fine model to use. And eventually we can even use those to develop kind of a different strategy, which would be like partial sums. Kids did this a lot with whole numbers, where they broke up the whole numbers. This is essentially expanded form, which you guys probably explored earlier in the year, right?
Yep.
So kids could fill this in, break this apart, and they're basically doing partial sums using place values. So 1 and 1/10, 600ths, we can still combine those back into 1 and 1600ths.
So we're really falling back on a lot of the strategies that should be familiar to the kids, just that they did it with whole numbers.
Yep. All right, another great concrete tool that we can use are place value discs. And those are very handy because we can actually move them around, pick them up, and group them.
Okay, I see this is the same problem as we used before, but now we're going to use the place value disc.
So just like we did with the base 10 box, we can show making that group of 10 and trading that. So I can trade 10 thousandths for 100. It's that whole base 10 relationship. It's just we started with the base 10 box because kids can actually line them up and they're going to be the same. They have some magnitude to them. Where the place value discs, if I flip those over, it doesn't mean anything. They're all the same size, right? And we can carry that over also into subtraction, where we know a lot of kids struggle, especially when they're regrouping, if they don't have enough. So I need to subtract out 6 thousandths. I don't have them. Where can I get them from?
Yeah, you might have to check with the hundredths there.
We're going to take one of those and trade it in for 10 of our thousandths. So we're doing the same thing we did with the base 10 box, just here. Now we're subtracting each way with our place value discs. And remember how we had a drawing of base 10 box earlier?
Right. Yeah.
A lot of kids aren't very good at drawing those.
This will be much easier.
What do you think they could draw to represent these?
So they could probably just draw circles, right? And then just fill them in.
There you go. And in the beginning, they could write the values of the circles, but if you're just putting these circles in the right place value, it doesn't really matter if you're writing the value in there eventually.
But this is continuing to add understanding to the addition and subtraction with decimals that the students are doing.
Yeah, this is the same thing they could be doing. Really, one student, if we're working in pairs, I could be modeling this with the place value discs while you draw this picture out of what we're doing pictorially. And both of us would want to record our values while we're doing that. All right, let's look at this whole number subtraction problem.
Okay, these are the ones where the students always struggle, Joe, because it's regrouping, cross zeros, all that. They always struggle with that.
We're going to cross off 9s, 10s, what goes where.
Yeah, no one knows.
So I do have the number line here. We want to connect to some of those whole number strategies that kids use in the past. What do you notice about these two values if I put them on a number line?
I mean, they're not going to be far apart.
Yeah. So let's use a benchmark number that's in between like 1,000. And just like you said, 1,002 is right there. 997 is right there. Now are you thinking of maybe a different way you could go about finding the difference?
Yeah, I mean, seeing it this way, obviously if I just count up, that's going to be way easier.
So at times when the numbers are close, this is a much easier method, especially when there's a lot of regrouping involved. I could just count up and maybe chunk that number out. So that was with whole numbers. Do you think we could use a similar strategy with this now that we're in a decimal?
Yeah, you should be able to do it the exact same way.
So maybe now our benchmark number is one whole. We have 1 and 3 thousandths, 997 thousandths. Well, really, those are only 3 thousandths apart. And if I have two jumps of 3 thousandths, that's only 6 thousandths. No regrouping. And we can continue that. These values are starting to get a little bit farther apart, but I can still break them apart and still chunk them up. And especially kids who struggle with regrouping, thinking addition instead of doing subtraction is often a lot easier.
Yeah, and again, this is falling back to the same strategies that worked for them before, so they're making a ton of connections here.
And this could be something that if we're giving the kids the opportunity, we're maybe giving them the number line, they're able to apply these strategies in a new way. So this is kind of like a partial sums that we saw earlier, but just using partial sums to count up. So remember back we said procedural fluency and a standard algorithm?
Yeah, and I know I was wondering about that a standard algorithm, not the standard algorithm. So
I'm sure in our country we're used to there's just one standard algorithm to add and subtract. But there actually are any algorithm that a student will use that, most importantly, it's efficient, it's accurate, and we can sort of apply it in new ways.
Oh, there was multiple ones like that describe that.
Yeah, so here's that same kind of thinking. I can do that chunking up. Maybe I'm going to write it a different way. I don't need the number line. So if I start at 67 thousandths, let's add 3 thousandths, I get to 70 thousandths. Now what do you think I could count up again here? If we're at 70 thousandths, let's just count up 30 thousandths to get to 100 thousandths, or 1/10. And now that's an easy jump to get to 304 thousandths. And maybe they could think of different ways that they could jump, and that's fine. But ultimately, I want to look at all my jumps. If I can visualize this on a number line that I've been doing before, I now see that this is just a couple of jumps, and I'm chunking it together to find that difference.
So this would be considered a standard algorithm there then.
That definitely would. And it's not to say that we cannot use what we're traditionally used to as a standard algorithm, which would be the same problem right here. Perhaps we want to record next to our pictures, next to our place value disks of the steps that we're doing. So what does it mean to truly take that tenth? When I'm crossing off my 3 in the tenths, I know now I'm taking one of those tenths, I'm trading it for 10 hundredths. And here's that regrouping across a 0, which is especially difficult. So this is why we end up with 9. Watch, we have 10 hundredths, but I need to regroup again. So I'm going to take one of those hundredths, trade it for 10 thousandths. Now I don't have 10 hundredths, now I have 9 hundredths. So that step that maybe can be especially tricky for kids, at least if they've got these pictures, they can rely back on that method. And then we go back through.
It just shows too how this one algorithm isn't always the most efficient. So being able to understand a couple of them gives students options.
Yep, and we see that third bullet. We want students to be able to justify why it's working, and that could mean comparing to another student's method as well. So just real quick, some possible misconceptions that we see students who are struggling. Here's some things you can do. We can't just tell them line up the decimal point if they don't have that place value understanding. They should still have experiences using concrete materials and those place value charts. And something that we didn't really talk about, but a little bit, is first stop and estimate. Before you just start writing something down, estimate what your difference or your sum is going to be. So if you make an error with that place value, you can go back and check with that estimate.
Yeah, that's one of our thinking and reasoning standards.
So just to check back to our CRA, here's all of our concrete tools we could be using: base 10 blocks, place value disks. Eventually we're drawing pictures of those, maybe making some models on the number line, and ultimately getting to an abstract, some kind of standard algorithm that works for you.
I think my biggest takeaway here, Joe, is all of those components that, just looking at these 3 islands, I can remember doing some of this work with whole numbers.
Mm-hmm.
And it's the same process. I just want to make sure I'm building that understanding, doing the same thing now that we're working with decimals.
Yep, I think they'll make a lot of strong connections, and it will be better embedded. All right, well, thanks for tuning in to Adding and Subtracting Decimals, and we will see you next time.